Hello everyone, my name is Tyler Welton, and I'm going to talk about continuous integration systems or continuous delivery systems and how we can use them to further hack the planet, and more importantly, how this is changing the attack surface for networks across the board. Specifically in my talk, I'm going to be referencing systems for application development and hosting, cloud hosting sort of environments, although a lot of this can be done internally as well. If you were hoping to watch about an awesome talk that's probably far superior to mine about Stuxnet being disassembled or whatever was happening, that's not this talk. That got canceled. So if you suddenly leave, I won't be offended. It's okay. But this should be interesting too. It's very pertinent to a lot of the application infrastructure that's being presented in a lot of the services that we're all consuming. More and more and more cloud trademark systems are changing the way that these environments are being built. And so basically my talk is going to be about that sort of evolution in the network and what that looks like to a red teamer, but also to some of the security benefits as well as these new systems arise. So I'm Tyler. I go by Spacebox on Twitter and IRC and GitHub and a few other places. But my day job, I am the senior security engineer at a software development company here in Nashville. Whatever that means, titles are sort of arbitrary, but I do red team, blue team. I help with policy writing. I do all sorts of stuff. And we're slowly getting to the point where we're growing out a security team to sort of specialize in certain areas. But I do a lot of web application pen testing, a lot of network stuff, as well as intrusion detection, system maintenance, things like that. Security hardening around our automated deployment systems, all that kind of junk. Yeah, so a lot of it is network level. I would say the network that I'm working on is kind of an atypical network. And we'll talk about sort of the de-evolution or the infrastructure as code sort of architectures that are sort of coming out now. But that's a lot of what I do day in and day out, and it's to support a web application that is deployed in a continuous fashion. You'll hear this term, continuous integration, continuous development. But we're going to cover what that means too. Also, I'm not 17. I just thought I'd say that because a lot of people think I'm really young. So I'm 30, and so if I won't get carded at Rated R Movies, which I occasionally get carded with my wife, Rated R Movies, and it's hilarious and embarrassing at the same time. But I thought I'd confront it here so you're not like, who's that kid up there talking to me about continuous integration environments?
This kid from St. Petersburg that did all the cheesy on that.
Yeah, I'm the guy, yeah. So an overview of what I'm going to be talking about is we'll cover it's going to go high level. It's going to stay kind of high level until the very end. I'm going to get into some low level exploit type stuff. But I want to get the basics covered so at least people know what I'm talking about when I say continuous integration. We're going to cover this concept of microservices, and it's a software design concept that has kind of changed the way that a lot of companies are building software and deploying software. It has implications beyond the actual function of the structure of the software that's running, and actually has huge implications at a lower level into the infrastructure and how the infrastructure is managed too, because the infrastructure seems to be being guided by a lot of this code is dictating the infrastructure and not the other way around, which is kind of an interesting concept. We will cover containerization, although in continuous, the large majority of containers these days we're going to be talking about Docker, although containers have been around for a very long time. Docker has sort of changed the way that containers are shipped and built code. So I'm going to say containers in this high generic sort of fashion, but what I'm really talking about is Docker and maybe other similar sort of implementations like Docker as well. After the overview section, I'm going to talk about how these infrastructure components are changing the attack surface. There are a ton of security benefits as a blue teamer infrastructure type of person to these, to continually deploying systems. So we'll cover some of that. I had to mention the 5th of November because I'm at a hacker conference on the 5th of November, and I just felt like that was the right thing to do. So we'll cover some tactics, although a lot of the hardened tactics that we find in let's say the red team, the sort of kill chain that's been presented to us about how we're going to, we're going to scope out what's on a network, we're going to exploit, we're going to pivot, these sorts of things start to sort of change. And I'm not necessarily going to present any hardened tactics per se, but just make people aware of some sort of things that are happening in these build processes that are often overlooked and can lead to a breach on many levels. And then I'll get some examples. So continuous integration as a high-level concept is this concept of taking code deployments and deploying many times a day or a week versus the old sort of method of application development where you go, hey, when's version 0.02 of this software coming out, and then you push it to all your clients, and you all use continuous integration systems if you have Gmail or any of these other things. They push changes all the time. Netflix, any of these SaaS-based services that we all consume all the time are getting changes pushed to them continuously. Some, I think, Etsy claims 35 deployments of production a day. I don't know how legitimate that is, but in this case, it's getting to the point where small changes in code can be deployed rapidly and without downtime. So yeah, deployment might be like you move the button, 6 pixels to the left or something like that in the application, and that counts as a deployment. But regardless, a lot of this deployment stuff, you're seeing a shift. Not that code wasn't stored in repositories before, don't get me wrong, but repositories are becoming the central point at which a lot of this is managed, for good or for bad. We'll take a look at that in a little bit, but builds will be triggered from pushes to a repo somewhere, which will then, if the build is successful, then trigger an entire deployment, maybe even including server stand-ups and things like that. It's all automated based off of repos. Additionally, with the containers that we mentioned before, and we'll cover in a little bit, containerization, which is not a word, but I'm using it, has led to container repos. So if you're familiar with Docker Hub, we are now standardizing images, and we're putting them in a semi-public forum, even though you can have private repos. They're still repo-centric image and deployment. So, as I mentioned before, a lot of this is in sync with automated builds. But one thing to really note is that it's not just the code now that's being automated. Infrastructure from a network level on up is being automated. So with AWS and Azure and Rackspace and some of these cloud hosting providers are allowing this, but a lot of these stacks that they're using are now open source, and so people that are, companies that have their own data centers are able to implement the exact same stacks that the paid service would implement as well for continuous deployment and resource management. So whereas before you would have code that would be built and then you would need some sort of management to set up these servers, now it's getting to the point where servers are code and infrastructure is code, and a lot of this can get spun up in an automated fashion in the exact same way that code would get deployed. So let's talk about microservices. Microservices is a concept more than it is a real thing, and that's not, some people kill me for saying that. I think the idea here is that it's an application development theory, and the theory is that you have this large, what in the DevOps sort of circle they call the monolith. You have this large monolithic application, and it is a single binary, and it takes a billion years to compile, and then, and if you make a change to CROD, you have to recompile this thing and send it out, which incurs downtime unless you can do rolling deployments. And even with rolling deployments, you're still sort of incurring downtime, at least at an infrastructure level. So this idea of microservices is you take your application, you break it up into small functionable things small programs that all interact with one another, but these small programs do one or two things, maybe max. That way, if something breaks in that system, just that portion of the application is broken, and if you've done your interaction code and kind of business logic and logic handling of those other services, they won't necessarily, roll over and die because one of these services went down. It also makes deployment extremely fast. This is where I was talking about code. Code changes the way that infrastructure is deployed, and not necessarily the other way around now, because you have these microservices that are being deployed, and they oftentimes are shoved into a single container. So you have a single Linux container that is running a single service, and then you have a whole cluster of those services running and interacting with one another, and that makes up applications. I think it's Google that claims that they're running everything off of, I think they say everything's running off of a container in Google, for all of their services, Gmail, search, whatever. I don't know what containers, Docker, probably others. But, so the single points of failure thing, I listed here. Microservices can eliminate single points of failure in an app. Basically, that means if the app crashes, it's just that portion of the app. This is not necessarily always true. This is subject to the authors of the other services and how they handle problems with those. But it's one of the ideas. And also, as far as like a company team working on these services, they're sort of autonomous in that other teams can sort of, you have a feature team that's working on one service and one container, and then that will be deployed to a single environment, single container and environment. So it's changing not just the code and how the code is running, but my point is it's changing the servers and the infrastructure that supports all of this, as well as even the teams that are building this. So it's really shifting the way things are, at least from a development perspective, and also from an automation engineer's perspective. So in theory, picture-wise, here's a good picture of what a microservices type service would look like. The black node being what the user sees. The other white nodes being various interacting pieces of that are each microservices that contain some sort of functionality. In theory, it looks like this in your brain before you start doing it. It looks like this big, awesome fractal of perfect order. And then you start to implement it, and it looks a little bit like this, which is okay because this is sort of the build I don't want to dog anyone for making a child's art, but eventually you work and you get to something that looks like this, which is kind of the original intent. You probably won't ever reach fractal state, but it's fun to dream. But going back to this picture, although this hopefully doesn't last very long, once these automated systems get down to deploy these, you sort of work kinks out. But this children's art phase, which is the best metaphor I can come up with, and I know it's a medium, but this phase is where we're counting on configuration oversights that don't get fixed in the automated processes that follow them. So what goes away here, some remains, and that's what we're looking for from an attacker's perspective, when we're looking to intrude these systems. So we need to talk about containers. I don't claim to be a super container expert. Like I said, I'm going to be referring kind of to Docker here instead of Linux containers as a whole, but it really is Linux containers as a whole. Right now, originally Docker it sat on Linux, and it think chroot for changing root for a directory. That's like, and also kind of think virtualization, although do not think virtualization because it's not virtualization. What it is it's services that have limited scope and share kernel functions, or share the kernel on a host, but they are an image in and of themselves. So you use like a Linux image. It might be stripped down to bare necessities and dependencies that you need for the function of that service, and then you spin it up in a container. It shares some host resources, but for the most part, it's isolated. in theory, I shouldn't say in theory, they do have it on Windows. I've never used I've never used Docker on Windows, so I have zero anything to say about this. It's API, it's not trying to emulate the Linux kernel. It is Windows apps running on Windows. I just don't know what that looks like from a containerization perspective, because kind of the original purpose of Docker was to further and make easier Linux kernels, or Linux containers. It's not new, but the way that Docker is changing the way it's being used is sort of new. Before, a lot of times you would have a container, and the way that people traditionally have used Linux containers is that they sort of treat it like its own operating system, so they have multiple things, like multiple stacks, or a stack of things running in that container, whereas the Docker and kind of the way they've helped shape the way deployments are done, you really have a service running in a container. And if you need another service, you should probably spin up another container. And right, I mentioned having as minimal of an OS as possible. I think there's right now Docker is supported Linux image is Ubuntu. I think it's still that, but they are moving to Alpine, which is an extremely bare bones, ripped down version of Linux, such that when you have a container, you only have the dependencies of Linux that you absolutely need in order to run your thing. So I've talked a lot about this. Docker Hub is the GitHub of Docker containers, and it is the central repo which holds your images and Docker files. And so you would do something syntax-wise, Docker pull, and you pull down an image, and there you go. You have your new, usually it's built on some version of Linux that's existed before, and then you have this thing called a Docker file, which goes into your bare, naked image, and it builds dependencies. You apt-get all your stuff, or APK if you're on the Alpine image. And then you build your code, you map all the ports, et cetera, et cetera. All right. So I'm going to use the terms old and new. Old infrastructure being maybe the way of deploying code to maybe a more data center-centric sort of thing, where it's not automated all the way through. You don't have containers being pulled down. But I don't want it to be confused with new is better, old is bad, because that's not the case. The new way has a lot of security benefits. It also has some problems. And the old way has traditionally led to attack vectors that have been sort of standardized. So you have, if I say I'm going to pivot on a network, people kind of know what that is because it's a pretty common thing. People kind of start to get things in their head about what that looks like when I break into a box and I gain access, and if I get Kerberos tickets or whatever, and I can start pivoting, people already kind of know what that is. Whereas in some of these systems that are very different, there's not really any standards from an attack perspective yet, which is always the case with anything new. Security always has to follow the tech. But let's see here. The physical limitations of infrastructure are disappearing, and what I mean by that is not that the physical servers are disappearing, but with hosted environments like AWS and Azure, et cetera, they are virtualized. So when you get a network interface card, you're not really getting you might be getting a network interface card, and you might be getting this virtual thing that functions like a network interface card. You're not really getting a server, you're getting a VM of sorts that's hosted on this whole shared environment. And so that has implications. The pieces of this are all the same, but they're virtualized versions of the real thing in cloud-based environments, at least. I don't want to say that across the board, because that's not entirely true for groups that are using these automated tools in like real data centers. But we need to talk about tools. So repos and webhooks, we've already talked about repos. Webhooks is nothing new. It's a fancy term for, hey, I'm listening for something, and when something occurs, it triggers an event, and it talks to me, and then I do something. That's all a webhook is. There are build tools. I put Octopus on here. I shouldn't put Octopus. It's a deploy tool, although it can do some build stuff. But build tools will take code and compile them in for whatever they need to be compiled for. Or if they're a scripting language, they don't compile them. They just, containerize them and then get a thumbs up or thumbs down. Some of those tools are drone. Octopus is not a deploy tool. Or excuse me, it's not a build tool, it's a deploy tool. And some kind of crossover into, or they allow for automated scripting, so you can kind of turn them into something like a build and deploy tool. With containers, you don't necessarily have the same infrastructure as before. You have these, you're getting these programs that are containers are living on a cluster of hosts. So you have these programs like Rancher that will go out and you'll say, hey, I have these 20 Linux servers and I have a container, and I'm too lazy to figure out where that container should go. So you can see the cluster and you know exactly where space is free and you can go deploy my container for me. So that's what these services are. But a lot of these services are doing their deployments based off of triggers either from builds or from webhooks coming down from repositories. And then infrastructure management tools. There are templates in AWS, Azure, and some others that will actually build your infrastructure. So infrastructure is now thought of as infrastructure as code, is a term you'll hear kind of thrown around, but it's true. So you'll have JSON templates that basically build out everything for you. It'll build everything from the subnet level to your firewall rules, to your storage accounts, to your, then it'll build the servers and attach the NICs and then apply the appropriate everything to that. And then on top of that, you have your configuration tools like Chef and Puppet and others. Some of these tools can do the deployment part as well. My experience has been used to use something like Chef or Puppet for configuration. So once the servers are up, then you use these systems to go through and standardize the configuration of those servers, but you can also do them to do deployments as well. So the traditional view we have here, I just drew some really crappy diagrams. A guy talking to the cloud who then talks into your environment through a firewall of some sort, and then it talks to a cluster of servers where the apps are hosted, and maybe that app has some logic in it that talks to a database that sits behind, and another firewall. And so the network, with a little checkered off section, would be sort of your kind of traditional DMZ architecture, so to speak. It doesn't look that much different on sort of the new cloud-based infrastructure. Everything past the initial firewall there would be in a big bubbly cloud if you're talking to a marketing diagram, because it would all be hosted. And there, instead of the hosts, I have a cluster of hosts that are hosting their containers. It really doesn't look that much different, though. You have your database in the back end, perhaps, maybe you have it on shared infrastructure, hopefully not. And you have your traditional sort of segments like before. The thing is I have code that can write every single bit of this. I have code that can write the firewall deployments. I can spin up subnets, which are the checkered boxes around. I can spin up the database servers. I can spin up the hosts. I can spin up the containers. I can deploy to the containers. So then really quickly, I can do something like this, where I just scale out really quickly. If I need more servers, I don't worry about it. I just deploy the code. So this leads to a lot of really good things from a security perspective. There was a speech I saw where someone had claimed that continuous deployment was their #1 greatest security feature. And I think to a degree that's correct. If there are bugs in place, these bugs, a vulnerability in an application, let's say, so we're working code level now. A vulnerability in an application can be deployed to much, much quicker. We don't have to incur downtime. We don't have to notify users of a new version of their software coming out. We just deploy it. Same with infrastructure. If infrastructure component goes bad, we can just spin up a new one, or if we need to scale really quickly, we can spin them up. If we're not using any, we can tear them down really quickly. Same with patching. Patching can be put into all of these systems, so you can now harden your systems on a cadence, not that you couldn't before, but it's part of the deployment process, which is happening hopefully really frequently. So I mentioned the automated patching portion. This can be good and bad, and I don't need to stay on that too long. I feel like most people know that if you pushed out patching blindly all the time, it can lead to bad things, and that's not unique to a continuous integration environment. That's unique across the board. let's see here. You can standardize images, not that this couldn't have been done before, but you can now easily reference and change images and switch them out. The saying is treat your servers like cattle, not like pets. So if your pet gets sick, you call the vet and you take it to the vet and it gives it medicine. And this is where sort of the security end comes into things. And they give your pet medicine, and maybe your pet has cancer, and that's really bad. So you pay an exorbitant amount of money because you love your pet and you want them to not have cancer anymore. Well, that's fantastic. In the older method where you're maintaining a physical server with a physical NIC, which is hosting your product or your application, that's fine. If you're a farmer and you have a cow, you don't have Fluffy the cow, because you don't name your cows, you number your cows. And if one of your cows gets sick, you might call in a vet. But if it's really going to get that sick and you don't want to infect the other cows with the sickness, you shoot the cow and you get a new cow and you assign it a new number. And while that's a brutal sort of analogy, that's the way it should be with the security of the servers. If you have a box that's compromised, you may need to get, don't hear me say kill it right away, but you may need to get forensics evidence of it. You may need to contain it and observe the malware doing its thing if you want to, obtain that information. But with continuous integration environments, I can completely remove it. I don't have to worry about maintaining or fixing or mitigating this problem. I have an entire template with an entire standardized image that I know is good. This one happened to have been contaminated, but I can just kill it and bring it back with and reassign a number to it, and it's back with the herd, so to speak. So there are some huge security benefits to this, because aside from forensics gathering, forensics evidence gathering, and maybe some analysis of malware, there's not really a need to keep it around, and it's easier than ever, and it's not any more cost efficient to do one or the other. It's cost the same to tear something down and spin it right back up again, except good. I won't spend too much time talking about Node.js as a language, because we don't need to get too vendor specific here, but from an application perspective, the vulnerabilities that were cross-site scripting and script injection and things like this are now, with the advent of server-side code that is a scripting instead of compiled. Not that it wasn't necessarily before. You can have server-side things written in scripting languages, but when you have an entire stack that is built up of scripting, you get these same client-side vulnerabilities that are now able to trigger things on servers, which is not good. So you've expanded the attack vector for cross-site scripting now. And a lot of this it's a little more difficult to pull off, but rather than, tricking someone into going to a website they shouldn't go to, I'm now able to actually execute functional code on a server that's probably in a privileged environment. So I'm not going to go into the details of how or why or when, but I'm going to make it known as to that this is a new, heavily growing area of attacking web applications, because it quickly transcends from web application testing into infrastructure and network pen testing, because it's taking formerly web application attack vectors and now it's making the availability of exploitation a lot bigger. Another area in continuous deployment is often overlooked in the industry as a whole. This portion of the industry is moving so quickly, and these tools are coming out, and methods are being built and sort of, I won't say standardized, but there are common practices that are being done that are not secure, don't have security in mind, and also are ahead of security in their functionality. And some of this with containers, when we want to spin something up really quickly and put something in it, we are passing credentials to them in unsafe manners, and in an unsafe manner. And so, whereas before you might have some sort of key store or hardware key management system, which was extremely hardened and rigid, and it took an aeon in order for someone to get a key in there, let alone write some software to properly do the correct 68-way handshake and get the key back out to use for one call and a function. Now you're having, because it's so quick and you're building these systems so quickly and deploying them so quickly that people are just kind of throwing credentials in and going, well, it's a container, it's confined, right? I mean, it's confined to its little namespace or whatever it has. So it's not, there's no problem with loose credential handling because, it's just one container. Which leads to another problem of securing containers in general. It's not extremely trivial to break out of a container or anything like this, but there have been some well-known vulnerabilities with with Docker that have actually led to container escape, where you can escape, or privilege escalation, or even at the user level, your effective user ID has not escaped into the host. You have you haven't gotten root of the box. That's what I mean. You may be able to. There have been some vulnerabilities where you can at least write to the host file system, things like that. It doesn't. For the most part, these containers are pretty well at an image level and a daemon level, pretty well hardened. But you still have to look out for this, and especially when you start mapping things to these containers from the host. But we'll get to that in a second. And configuration oversight would be the other large one. So to start, there's this thing called environment variables in Linux and in Windows as well. You know what environment variables are. They are variables in an environment. And what this means is when you put something in an environment variable, it is shared in that environment. So when you share passwords in an environment variable, they are not contained to the service that is using that environment variable. It takes a 3-letter command to dump these credentials when you store them in environment variables. These variables also get pushed to the stack when services run. And what this means is you might have written the fanciest error handling code in your entire infrastructure, but if another app crashes, you have no idea what that app is going to dump in the stack trace or some other service that's running in that environment and where that stack trace goes, because oftentimes these containerized things are sending standard out to their logging environment, which means, or standard error to their logging environment. So if it dumps, it's going to spew your credentials to the four winds. So these are things that are starting to be addressed, but the way that they're being addressed is as problems, and then services being built on those problems to handle those credentials. So services to handle how those environment variables talk, when we probably shouldn't have been storing credentials in environment variables to begin with. Yeah, Docker right now runs as root. This you can run as a non-root user, or as long as you have root privileges as that other user. So this is only really a big issue if we encounter container escape, which we do. It's not as common as it maybe was in the infancy of Docker, but it's still, it will happen more. You will find programs that will escape from that container onto the host, and what do you know? You escape into root privileges right away. So that's extra helpful when trying to clone a system. The contents of this containers are subject to whatever you can pull down into that image. The Docker file is what builds Docker images. So unless that container has been compromised, you are subject to whatever the Docker container has. In container escape, which I've mentioned, there is a study that was done by the BanyanOps.com, and they pulled down all the public these are public repos, mind you, not private, but repos from Docker Hub, and scan these images, and 30% have vulnerabilities. Something like 30% have high and above vulnerabilities. The percentage goes way up when you get to medium and ranked vulnerabilities, and I'm not entirely sure what they they've presented what they use to categorize and do their risk assessments to low, medium, high, whatever. Yep, and existing poison damages. So, because these systems can be blown away and rebuilt so quickly, the chances of, don't hear me wrong, this will still exist, but the chances of you scanning a network and finding a system that is outdated the chances of that going down, chances of that are going down. So this is assuming post-compromise of a web application environment. You're in the network and you're scanning around for other systems. The likelihood of you seeing something that's out of date is starting to get a little lower. It will still exist, so don't hear me saying this is not a problem anymore. It will probably always be a problem. But the configuration of these systems and the way that these components talk to one another is the biggest vulnerability. We have new shiny things that come out, and we like to deploy them in our environments. But the problem is the person working with new shiny number one that is supposed to actually build new shiny over here in their environment, since they're working in self-contained groups on self-contained services, they often neglect the interaction of these services, and I'll give an example of that here shortly. So at a logic level and at a personnel level, a lack of understanding of the interaction between these components is probably the biggest vulnerability that I've come across with these systems. So let's give an example real quick. Got Mr. Man here, and he wants to talk to GitHub. This was a vulnerability that I encountered on a pen test. And this company had a public-facing repo for not just for their code, but for the community code. Like, we want to contribute to the open source community. We've written some of these tools, and we want to make them available. We have our private repo too, of course, for the management. But we want to make three of these services we've written. We want to give back to the community, so we made them public. So the high-level concept is some guy or gal wants to make a PR to GitHub, which is pull request is, hey, I've made a change to your code. Here it is, and you can review. Now, the system that this company had in place sent a webhook down to a build server. In this case, it was Drone. Drone is a program that just takes and builds and makes sure that it doesn't barf all over itself when it builds, and then it sends you a message back that says, okay, cool, it didn't fail. So now you're cool to merge this code. So there's a few problems here. One, this code was being built before the PR was merged on a public-facing repo. So at a very low level, this guy or person can now make a PR and build something on someone's infrastructure just by making a PR to a public repo. So you can probably see where this is going. In this, there's this thing called a drone file. And what it's doing is giving commands as to how to build this software. It's not actually part of the software. It is, you have this repo, you have this code, here's some instructions and some things to run, and here's how you're supposed to build it. When you're done building it, hey, tell me, and I'll give you the thumbs up, and we'll be good to go. I noticed this when I made a PR to one of those repos, that I got this message back saying, hey, your build is good to go. And I was like, is this running a build for me? This is a public-facing repo. Well, it turns out this file here is contained in the repo, in the public-facing repo, which means that I can modify the config file. And I noticed here there's a section called commands. And so I decided to do this, just a basic echo statement, and go, I wonder what this does. I know a lot of these build systems have some sort of scope on what they can do inside the system. We give them permission to do X, Y, and Z at a shell level, but no more. So I just echoed back hello, and sure enough, I made a PR, did not get merged, I just made a pull request, and as part of that little dump of, hey, your build is successful, I saw hello echoed back at me, and I was like, oh, okay, this is interesting. What if I added 2 commands instead of echo hello, like make a backpipe and then pipe shell? And what if I also had a server somewhere that was listening on a port? And yep. So now I have root on the container in a, now hear me, on the container, not on the box, but with the env, just dump the environment variables. Now I have access to where it's storing information. I have network level access. Which brings me to another point real quick. If you gain access to a container, you still have network access. You can now pivot, which is what we wanted the whole time. We have root of that container, which basically means I can now start pulling repos. I can start pulling tools in. It doesn't really matter that I'm not root of the host, other than maybe some domain level stuff, because I can build all the things I want. I have root to the container, which means I can pull down whatever's in the apt repositories. So this was not a problem with the container. This was not a problem with the code repo. This was not a problem with Drone. Drone was functioning exactly how Drone is supposed to function. It was a problem with the configuration between all of these components. The person who's maintaining the repo did not realize that how the down-end build system was consuming that code based off of a pull request. Another quick thing to note is inside the network, now that we're inside in this example, scan the entire private IP range. If you're on a /24, scan a /8, just because you don't know what how virtual firewalls and virtual subnets are going to be configured, because you can basically spin them up with any sort of IP range, and the firewall rules will allow traffic. I don't need to explain that, but that's just one of the things. So that's my example. If you have any questions, hit me up afterwards. I'd love to hear more thoughts or experiences. I'd love to hear more experiences of these systems going awry. So yeah, thank you.